Hey guys, how you doing? This is Coach Scott. Hey, let's go over polyatomic ions real quick. So, and what we're looking at here, let's go ahead and go full screen so we can see this, right? When we were talking about ionic compounds, we introduced the concept of what a polyatomic ion was, right? And if you recall, we said then that a polyatomic ion is a discrete group of atoms that was bonded together, and they have a charge, and they act like a single formula unit or an ion, right? Yeah. And so these atoms are bonded together, and they're bonded together covalently. So these are some examples: sulfate, nitrate, carbonate. You should remember those, all right? So to draw these or to understand what they are, all right, if we're going to draw the Lewis structure for an ion, remember that it has a charge, right? And it's going to get that charge, one, by either losing an electron or gaining an electron. So if we have a negative electron or a negative ion, we got negative electrons. We have a negative ion, that means it has extra electrons than what it was supposedly to have according to the valence of it. So how we do that is we take the normal valence from the periodic table, and then we add the number of electrons to it to get the charge balance for that polyatomic ion. So let's look at ClO2, 1 minus. Chlorine has 7 valence electrons, just like this, right? It's got 7 valence electrons. It has, oxygen has 6 valence electrons, and there's 2 of those, so that means we have, well, 12 there, and it's got a -1 charge, right? So that means it has 1 extra electron, so we would say that this one would have 20 electrons. So that's what we're going to draw with it. I'm trying to get my pen out. Okay? So a positive ion, right, would not have the same number of electrons. It'd be like 1 or 2 less, or whatever the charge is. All right? So it's missing electrons. So we're going to subtract the charge of the ion from the valence count. With a negative ion, we're going to add. A positive ion, we're going to subtract. So let's look at ammonium, NH4, 1 plus. Ammonia has 5 valence electrons, 1 of those. Hydrogen has 4 valence electrons, so that's 5 plus 4, -1 to show that positive charge about it. So we would say that it has 8 valence electrons in order to draw that. Okay, so if we're going to draw ammonium, also on any of these electrons, I really would like you guys to include a bracket. Well, I don't like it. You will include a bracket or it won't be correct, okay? And then put the charge outside of it, right? Like that. So use the brackets, and this would be the Lewis structure for ammonium. And if you notice, if we're going to start drawing that, I'm going to go ahead and do this for you. Remember, ammonium had 8 valence electrons. Write that up there. So nitrogen would be center. We'll draw hydrogen all the way around it. All right, then we're going to add pairs if we need to around the outer atoms. We don't because hydrogen's full. Then we're going to do our count: 2, 4, 6, 8. It used the right number of electrons. I'm going to put brackets just like that, and then put the charge outside. So that shows the charge balance of that ion, ammonium. So I'll do a couple for you. So this is drag and drop. This is H3O plus hydronium or acid. All right, so let's go ahead and do that one. That's got a 1 plus, right? So hydrogen has 3. It has 1 valence electrons. There's 3 of those, so it's 3 times 1, plus the charge of or the valence of oxygen. That's 6. Then we're going to subtract the charge. That'd be -1. So if you add that up, that's going to be 8 valence electrons. Of course, oxygen would be center here. Draw your oxygen. Put the hydrogens around it. All right, add the pairs around the outer atoms. There's none to add. Then we have to make oxygen happy, so we're going to put a lone pair there because it needs 8. 2, 4, 6, 8. It's happy. Let's put our brackets. So that's hydronium. All right, not that shabby, not that hard, and that's what it looked like. Draw pretty. Let's do one more, and then yeah, let's do one more example. So I got, I think that's nitrate, NO3, 1 minus, going from memory. I hate that. Anyway, so nitrogen has 5 valence electrons. We're going to add 3 times the number of valence electrons of oxygen, that's 6, so we got 3 oxygens. Then we're going to add the charge, it's 1 minus, and that's going to give us our number of valence electrons. So that's 5 plus 18. 5 plus 18, that's 23, plus 1, that's going to be 24 valence electrons. Of course, nitrogen would be center because it's the lowest electronegativity 1. I'm going to draw my oxygens around there, like so, like so. Then I'm going to add pairs to make a full valence around the oxygen. Okay. And then we're going to count 2, 4, 6, 8. That's good. 2, 4, 6, 8. 2, 4, 6, 8. Now we're going to see how many electrons we have. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Ooh, we've already used our electrons, so now we're going to have to take one of those pair and put it down there. Now, which one do we use? Well, this is showing resonance because it doesn't matter which one of those oxygens I could do it. So I could really needs to draw like this, and then I can draw the other structures looking like that. We'll do oxygen like that because we already shown that it's got resonance. All right, then that oxygen. All right, and so this would be nitrate. I believe that's what it is. Anyway, and we'll do the others in class. Again, there's actually 3 of those structures. So, yeah. So we can ask this, how many valence electrons does carbonate have? Let's say I would do that. Carbon's got 4. There's 3 oxygens, 3 times 6, plus 2. So 4, 22, that's going to be 24 valence electrons. Okay. And we did the hydronium, that's going to have 8 valence electrons. Which is the correct Lewis structure for ammonium ion? And of course it needs to have brackets, that's pretty easy, that's going to be B. And which is the correct Lewis structure for the cyanide ion? Well, we've drawn this in class before. That's got a triple bond, so it's going to be B. B. Okay. And that's all we want to cover on that, guys. That's polyatomics. Remember, the discrete charged has either one less or a couple more electrons than what it should have. All right, and it's used in ionic bonding. Okay, guys, this is Coach Scott saying, hey, guys, appreciate you guys and appreciate all you do. And this is Coach Scott saying, see you later.